Hello students, in this video we will discuss about design issues of RPC. Mainly we have to deal with three issues that are important in understanding this concept. The first one is programming with interfaces, that is the style of programming promoted by RPC. The second one is the call semantics that are associated with remote procedure call. And the third one is transparency and how it relates to remote procedure call. Let us see programming with interface. We have already studied that usually the big programs are divided into small modules, and all these modules will communicate with each other for the proper functioning of a particular program. And the communication between these modules can take place either by two means. One is by means of procedure call between the modules, or the modules can communicate by direct access to the variables in another module. And there need a control for the possible interaction between these modules. And in order to control the possible interactions between the modules, an explicit interface is defined for each module, so that this interface will specify the procedures as well as the variables that a module can access from other modules. Let us see the benefits to programming with interface. One is that for any programming model, programmer is unaware of the implementation details. Also, there is no need for the programmers to know about the programming language or underlying platform used to implement the service. So this particular approach will provide a support for software evolution, in that implementation can change as long as the interface remains the same. That means as long as the external view remains the same, the implementations can change. Interface definition language. This is designed to allow the procedures implemented in different languages to invoke one another. That means the procedures implemented in one language can invoke the procedures implemented in another language. For that purpose, interface definition languages are designed. An RPC mechanism can be integrated with a particular programming language if it includes adequate notion for defining interfaces, so that if there is a provision for defining interfaces, RPC mechanism can be integrated with a particular programming language. And this is useful when all parts of the distributed application can be written in the same language. It is also convenient because it allows the programmers to use a single language. Now let us see the second design issue, RPC call semantics. Mainly three fault tolerance measures are discussed. First one is retry request messages. Retry request messages means retransmission of the request message by the client if it did not receive a reply from the server, or the server is assumed to have failed, so that there will be a control whether to retransmit the request message until a reply is received, or the server is assumed to have failed. The next one is duplicate filtering. Sometimes due to some issues, the client may send the request again to the server, so that it may happen due to a delay in the communication channel, so that sometimes the server will receive the request more than once. So duplicate filtering deals with controls when retransmissions are used and whether to filter out duplicate requests at the server. Next is retransmission of results. it will keep a track or keep a history of result messages that are sent to the client, and sometimes there may come a need to retransmit this particular result to the client. So it should be allowed or it should be able to retransmit this result without re-executing the operations at the server. That is called retransmission of results. And this shows the RPC call semantics and fault tolerance measures. Basically there are three call semantics. First one is maybe and at least once, and the next one is at most once. And this table shows the fault tolerance measures which are present or not applicable in the various call semantics. Let us see the first call semantics, that is maybe semantics. With maybe semantics, remote procedure call may be executed once or not at all. That means the remote procedure call will be executed once or it will not be executed. And maybe semantics arises when no fault tolerance measures are applied, and it have two types of failures. First one is the omission failure. That means if the request or result message is lost, either the request message or the result message is lost, it is termed as omission failure. Next one is the crash failure. This happens when the server containing the remote operations fails. The second one is at least once semantics. In the case of at least once semantics, the invoker receive either a result, that means the invoker will receive a result, or an exception informing that no result was received. But in the case of at least one semantics, the procedure was executed at least once. It suffers from the following failures. First one is crash failure. That means when the server containing the remote procedure fails. Other one is the arbitrary failure. In this case, when the request message is retransmitted, remote server may receive it and execute the procedure more than once. That means one time the request message is already sent, and due to some problems it may be needed to retransmit the request message, so that there are chances for the server to receive that particular request more than once, and it will be executed more than once, so that possibly causing wrong values to be stored or returned. Next is at most once semantics. In the case of at most once semantics, the caller receives either a result or an exception, same in the case of at least once semantics. But in the case of at most once semantics, the procedure was executed exactly once. That means the procedure will be executed only one time, and with that execution the caller receives either a result or an exception. But in the case of an at least once semantic, the procedure was executed at least once. Here it will be exactly once. Like the at least once semantics, the use of retries mask an omission failure of the request or result messages. And in the case of at most one semantic, the set of fault tolerance measures prevent arbitrary failures by ensuring that for each RPC a procedure is never executed more than once. That means a procedure is executed exactly once. The third issue is transparency. Transparency means hiding some of the implementation details from the user, so that it seems more easier and friendly for the user. That is, all the necessary calls to marshalling and message passing procedures were hidden from the programmer making the call. In the case of remote procedure call, it strives to offer at least location and access transparency. That means hiding the physical location of the procedure and also accessing local and remote procedures in the same way. For achieving transparency to RPC, middlewares can also be used. That means it will also offer additional levels of transparency to RPC. These are the three design issues for RPC. Thank you.